Okay, so as in the last video, we have started parallel combination, or you can say capacitors in parallel, right? In last to last video, we completed our series combination or capacitors in series. Series means same path. Then in yesterday's video, we started parallel combination or capacitors in parallel, right? We connected parallels, we connected capacitors parallelly, right, and we wrote the definition of the parallel combination or capacitors in parallel as well, right? What was it? Initially we made diagram, right? We made three capacitors, we connected them with the positive and negative terminal of the battery, and we were known that they're going to store the same potential difference, however different charges, right? So here we wrote the definition of the parallel combination or capacitors in parallel. When two or more capacitors, which means when three capacitors are connected in such a way, the positive and the positive terminal of a battery is connected to one common point. Now see, this positive terminal of the battery is connected with this one common point, right? And other of each capacitors are connected to negative terminal of a battery, and they are connected with this common endpoint, and this endpoint is connected with the negative terminal of the battery. This such type of combination is what we call the parallel combination or capacitors in parallel, right? In today's video we're going to consider these three capacitors, and we're going to see what would be same in the parallel combination and what would gonna be different, right? So we are going to consider now. So consider three capacitors, three capacitors, right, named as C1, C2 and C3, connected connected in parallel, right? Across positive and negative terminal of a battery of potential difference V volt, right? Of potential difference V volt. Each plates each plates of the capacitor store different charges different charges but potential difference is same in each plate of the capacitor, right? Capacitor. Now let's delve deeper in this definition and let's understand what I tried to write here to make you guys understand about the parallel combination or capacitors in parallel, right? Initially we consider C1, C2, C3, right? Consider three capacitors named as C1, C2, C3, right? They are connected in parallel. They are connected in parallel, right? Across positive and negative terminal of the battery. Across positive and negative terminal of the battery provided potential difference V volt, right? I hope till this everything is crystal clear to you. Consider three capacitors C1, C2, C3. They are connected in parallel across positive and negative terminal of the battery provided potential difference V volt, right? Thus each plate of the capacitor, they are gonna store the different charges, right? And we have named those charges as Q1 since that charges would be stored on the C1, then Q2 since those charges would be stored on C2, then Q3 since these charges would gonna store on the C3 means capacitor number 3. So they will gonna store different charges. However, same potential difference would be stored by these capacitors, right? So what we discussed, consider three capacitors C1, C2, C3. They all are connected in parallel across positive and negative terminal of the battery provided potential difference V volt. Thus capacitor store different charges but potential difference is same in each plate of the capacitor. In series, we got to know that the potential difference on the each plate would be different. However, they're going to store the same charges, right? But here in the parallel, they're going to store different charges. However, potential difference would remain same, right? So let me highlight this. Consider three capacitors named as C1, C2, C3 connected in parallel across positive and negative terminal of the battery of potential difference V volt, right? Each plate of the capacitor would gonna store different charges but potential difference is same on each plate of the capacitor, right? So now if we will gonna get the different charges on each plate of the capacitor, then how we gonna calculate those charges, right? Let's write here the general term which we had. The charge stored on the each plate of the capacitor would be directly proportional to the potential difference provided to it, right? This is the general equation. This is general equation, right? Charges stored on the each plate of the capacitor would be directly proportional to the potential difference provided to it, right? So when we remove this proportionality sign, we get is equal to and constant C, right? C is here the constant which is known as the capacitance of a capacitor or the ability of the capacitor to store the charges on it, right? It is basically the ratio of the charges and the potential difference. So here we are finding the Q, right? For suppose I need to find the Q1 means the charges which would be stored on the first capacitor. So that of course would be equal to C1 because we are finding for the first capacitor and potential difference would be same for the each capacitor. So V. So Q1 is equal to C1 into potential difference V, right? So now how we gonna find the Q2 means the charges which would be stored on the second capacitor. So Q2 would be equal to C2 into V because potential difference again would be same. However, we are finding the charges for the second capacitor, that's why C2, right? Then in the end Q3 means now we are going to find the charges for the capacitor number 3. So C3 into V, again potential difference would be same, right? So if you will find the charges on the first plate of the capacitor, that will be equal to Q1 is equal to C1 into V, then Q2 is equal to C2 into V, then Q3 is equal to C3 into V, right? This is all we have done today till the charges on each plate of the capacitor, right? In next video we will gonna find the equivalent capacitance or you can say total charges, right? Till now we have completely covered our series combination or capacitors in series, and we have almost covered our parallel combination or capacitors in parallel. Right now everything is very easy. What we did in series would be doing here as well, right? What would be capacitance of a capacitor would be equal to, how we're gonna find the total charges, we're gonna do everything here, right? So this was all for today.